Hello. Welcome to Vivek Physics. Today we are discussed about the current electricity, mean electric current. This is a first video lecture of the current electricity, and let us start one by one, step by step, each topic of the current electricity as like the electric current, mean concept of electric current, drift velocity, mobility and Ohm's law, limit of Ohm's law, combination of resistance, series and parallel. Combination of resistance, and this is a most important topic, most important lecture for the JEE exam and also NEET exam. And this is a most beautiful channel for physics on YouTube. You are most welcome here. Let us start step by step, one by one, each topic, each concept about the current electricity. Let us start initially. We are discussed about the electric current, right? Electric current. What is the concept of electric current? Suppose that this is a conductor, right, cylindrically conductor, and potential at point this VA and potential at point this VB, and this conductor connected from the battery mean external source. This is a higher potential and this is a lower potential, and potential difference maintain, mean battery potential difference maintain, mean both end of the conductor potential difference maintained by the battery, and potential difference higher potential minus lower potential, and this is a higher potential and this is a lower potential. And according to given diagram, electron always flow from lower potential to higher potential as like this, right? And due to flow of electron, mean due to flow of charge, mean electric current equal to delta q divided by delta t, right? Also written as I equal to q2 minus q1 divided by t2 minus t1, and unit ampere or coulomb per second. This is a flow of charge, mean current equal to flow of rate of charge, right? Flow of rate of charge with respect to time, known as electric current, right? This is a average value of electric current, right? Suppose that a uniform electric field, uniform electric current, if the value of electric current is remain constant, I equal to constant, in the situations known as uniform electric current. And for the non-uniform electric current, value of electric current variable with respect to time, variable with respect to time, known as a non-uniform electric current. And instantaneous of electric current, instantaneous current, value of electric current at present time, value of electric current at present time, known as instantaneous electric current. Electric current, right? And the formula of the instantaneous electric current I equal to dq divided by dt, mean differentiation function of the electric charge with respect to time, right? Mean I equal to dq divided by dt, and q equal to integration of I dt using limit with respect to time, mean t1 t2 t, mean from t1 to t2. This is a value of instantaneous electric current flow in the circuit due to flow of charge, mean electric current, concept of the electric current, flow of rate of charge with respect to time, known as electric current. And average value of the electric current, I average, mean total flow of charge divided by total taken time, mean delta Q divided by delta T, mean Q2 minus Q1 divided by T2 minus T1. Total flow of charge divided by total taken time, ampere or coulomb per second, right. Ampere is a SI unit of electric current, and example of the electric current from NEET exam PYQ and also JEE exam PYQ. NEET and JEE concept. Suppose that value of charge with respect to time Q equal to 5t square minus 8t. Find, this is a value of electric charge flow in a circuit, flow in a conductor, and find point 1 at t equal to 1 second electric current, and second t equal to 0 to 4 second electric current. Solve this problem. Initially you focus need of the question, demand of the question, how to calculate, how to solve this problem, how to calculate the value of the questions, the need of the question. Initially you focus what is the logic, what is the concept of the question, and also the need, requirement of the questions. Initially we calculate the instantaneous value of electric current, mean I equal to dq divided by dt, and I equal to d by dt, value of electric charge given with a function of time, mean 5t square minus 8t, and differentiation function using this formula of the differentiation, mean d by dt t power n equal to n t power n minus 1, and here electric current mean 10t minus 8, using given value of time t equal to 1 second, and put here I equal to 10 minus 8, mean 2 ampere. This is the value of electric current just after 1 second, mean this is a instantaneous value of electric current, instantaneous. Instantaneous value of electric current. Right. And second point, what is the value of electric current from 0 to 4 second, and this is a average value of electric current. I average equal to Q2 minus Q1 divided by T2 minus T1. Here T1 is a initial time 0 second and T2 is a final time. For the value of Q1 Q2, mean Q equal to 5t square minus 8t, and T1 equal to 0 second for Q1, mean Q1 equal to total value becomes equal to 0, right. And for the Q2, T2 equal to 4 second for Q2, and Q2 equal to 5 multiply 4 square minus 8 multiply 4, right, and Q2 equal to 5 multiply 16 minus 32, and Q2 equal to 80 minus 32. This is a value of Q2, and for the average value of the electric current, I average mean Q2 minus Q1 divided by T2 minus T1, right. Put value here, I average equal to 80 minus 32 minus 0 divided by 4 minus 0, and I average equal to 80 minus 32 divided by 4. This is a value of average value of electric current. And for the next question, next numerical problem, example second, this is a electric circuit connected from the battery as like this. This is a switch and this is a resistance, and here using ammeter for measurement of electric current flow in a circuit. I current flow in a circuit, here plus minus voltage, potential difference. The equation of electric charge root q equal to 40 minus 5, right. Find time when current becomes equal to 0, when current equal to 0, right. Suppose that after t time, current in a circuit becomes equal to 0, just after t time current becomes equal to 0, and calculate value of time, okay, right. From the formula of electric current, I equal to dq divided by dt, and here using a square function both side, mean root q square equal to 40 minus 5 square. Using identity of a minus b whole square, mean q equal to 16 t square plus 25, right, minus 2 ab, right, mean 40 t. For value of electric current, mean dq divided by dt equal to d by dt 16 t square plus 25 minus 40 t, right, and here value equal to 0 according to questions. I equal to 0 mean I equal to dq divided by dt, and this value also equal to 0 according to question language, and here 32 t plus 0 minus 40 t mean 40, and 32 t equal to 40 mean t equal to 40 divided by 32 mean 20 divided by 16, right, mean 10 divided by 8 mean t equal to 5 divided by 4. Just after this time current becomes equal to 0, flow in a circuit, right. This is a best example related to electric current as a given problem, as a given concept. And let us start another topic related to current electricity, mean drift velocity of the free electrons. Drift velocity, second topic second, drift velocity. Drift velocity of free electron. What is the concept of drift velocity? Mean velocity of the free electrons inside of the conductor, known as a drift velocity of the conductor. Here 2 points discussed about the drift velocity. Initial mean before connecting from the battery, conductor mean drift velocity before from the battery, right. This is a conductor, and before connecting from the battery, all free electrons move zigzag type motion, mean random motions, and potential difference both end of the conductor mean VA and here VB, potential difference mean delta V equal to VA minus VB, and this value becomes equal to 0 because VA equal to VB. No any potential difference between both end of the conductor, and in the situations all free electrons move random motion inside of the conductor as like this, no any fixed direction motion of the free electrons before connecting from the battery. In the situations, the average value of the velocity, average value of the drift velocity, drift velocity mean velocity of the free electrons inside of the conductor, known as a drift velocity, and average value of the drift velocity equal to displacement divided by time, velocity equal to displacement divided by time. This is a very conceptual very basic formula about the kinematics, and this value equal to 0 because because average value of the displacement of each free electron during random motion equal to 0, and due to displacement 0, velocity of the free electron drift velocity of the free electron must be equal to 0 because drift velocity equal to displacement divided by time. And this is a concept of drift velocity before connecting from the battery, and concept of drift velocity just after connecting from the battery, concept of drift velocity just after connecting from battery. And what is the effect of battery of the conductor? Battery maintain potential difference both end of the conductor. Suppose that this is a free electrons, this is a free electrons, and potential at point A is VA and potential at point VBB. Then battery connected as like this is a switch, and this is a higher potential, symbol of higher potential positive, and this is a symbol of lower potential negative. Potential difference V equal to VA minus VB, battery maintain potential difference both end of the conductor, and due to maintain potential difference both end of the conductor, battery lost its energy, and battery discharging situations become in a discharging situations. Sometime after battery becomes completely discharged, and potential difference equal to 0, no any potential difference both end of the conductor when battery becomes discharged, and after battery discharging no any current flow in a circuit because potential difference just after discharging of the battery, potential difference also equal to 0. But before discharging of the battery, battery maintain potential difference both end of the conductor, and electron flow from lower potential to higher potential. This is a lower potential, negative terminal is a symbol of lower potential and positive terminal is a symbol of higher potentials. In the situations, all electrons flow from lower potential to higher potential inside of the conductor, In the situations, the velocity of the free electron inside of the conductor known as a drift velocity, and value of drift velocity can be calculated from the first equation of motions, just after connecting from the battery, V equal to u plus at. This is a first equation of motion. From first equation of motion, and Vd equal to ud plus a time t, and t is a relaxation time, right? T is a average relaxation time. What is the concept of relaxation time? Suppose that electron move inside of the conductor before connecting from the battery, and each electron collide with neighboring electron and also from the atoms. In the situations, the average value of the relaxation time represent from these symbols, and the value of the accelerations q e divided by m, and here q is a charge of one single electron equal to e in accelerations e e divided by m. Here small e is a charge of one electron and capital is a electric field of the conductor, and m is a mass of electrons. This value put here, and ud also equal to 0. In the situations, calculate drift velocity Vd equal to E divided by m multiply average relaxation time. This is a basic concept about the drift velocity just after connecting from the battery, right? This is a basic relations. And for the third topic, mobility. Mobility of free electron. What is the concept of mobility? Mobility mean mu equal to Vd divided by E, right? Vd divided by E mean the ratio value of drift velocity of the free electron and electric field of the conductors. This is a concept of mobility of the free electrons, and mobility is directly proportional to drift velocity, and mobility is inversely proportional to electric field. This is a fundamental relations between mobility and drift velocity, and also mobility and electric field. This is a basic logic about this, right? And next, relations between drift velocity and electric current. In relation between drift velocity and electric current. Right. Suppose that this is a conductor, and conductor connected from the external source as like this, and battery maintain potential difference both end of the conductor, and potential difference here V. This is a higher and this is a lower potentials. All free electrons move along this directions, mean from lower to higher potential inside of the conductor. In the situations, the value of drift velocity Vd, and this is a length, and length equal to Vd multiply time interval delta t, right? And solve this derivations. Number of free electron in per unit volume equal to n, and also charge in per unit volume q equal to n multiply E. Here n is a value of number of free electrons in per unit volume. Its unit per meter cube, meter minus 3 per meter cube, and such as total charge q equal to charge of in per unit volume multiply volume, right? Mean q equal to Ne and volume A multiply L. L is a length of the conductor, and here q equal to I multiply delta t, equal to NEA, and here L equal to Vd multiplied delta T. Delta T cancel out to each other, and here I equal to NEA Vd. This is a basic logic about the drift velocity and related to electric current. In the situations, two most important examples related to JEE and NEET exams. Point 1, uniform cross section area. Uniform cross section. As like this. This is a higher potential and this is a lower potential, and all electron flow from lower to higher potentials. In the situations, velocity, drift velocity, mobility and electric field at the both end, mean this is a x point, this is a y point, this is a y point, right. Mean velocity remains same at both end, and electric field same, current same at the both end, and current density remains same at both end of the given conductor, right. This is basic relations, but in non-uniform cross section area, as like this. And this conductor connected from the battery. This is a higher potential and this is a lower potentials. Electron flow from lower to higher as like this. And according to given diagram, electron flow as like this. In the situations, this is a x point and this is a y point. Drift velocity Vd at y point is smaller as compared to drift velocity at x point, and electric current at y point is smaller than as compared to electric field at point x, and current density at y point is smaller than as compared to current density at x point, but current remain constant. This is a basic relation, basic concept about this topic, about this logic. And next topic for discussing Ohm's law. What is the basic logic of Ohm's law? Topic number 4, Ohm's law. Ohm's law is not universal law. Ohm's law is a limited law. Ohm's law valid only conductor materials. Limit of Ohm's law. First, Ohm's law valid only conductor material. Second, Ohm's law not valid, does not valid for semiconductor and also insulator material. Right. And third point, in a conductor material, resistance, if resistance is remain constant, then Ohm's law valid. In conductor material. Right. If resistance of the conductor material it change with time, then Ohm's law invalid for conductors. Mean for the Ohm's law resistance must be remain constant, and resistance depend some basic parameter, resistance depend some basic parameter. Point 1, resistance depend length of the conductor, mean resistance directly proportional to length of the conductor. Suppose that this is a conductor material and this is a length, mean resistance depend the length of the conductor, resistance inversely proportional to cross section area of the conductor, this is a, and resistance directly proportional to temperature of the conductors. This is a main criteria of the resistance, because resistance is a property of materials. Resistance does not depend on potential difference and electric current flow in a circuit, right. Mean from this equations, R directly proportional to L divided by A, mean R equal to rho L divided by A, rho L divided by A, and rho is a resistivity, rho is a resistivity of the conductor, and resistivity equal to 1 by conductivity, mean resistance R equal to L divided by sigma A. This is a formula of resistance with respect to conductivity of the conductors, right. In the situations for the explanations of the Ohm's law, this is a resistance wire, value of resistance R, and connected from the battery as like this. This is a source plus minus V volt potential difference. Suppose that here potentials VA and here potential VB, then potential difference maintained by the battery, mean potential difference equal to higher potentials minus lower potentials. And for the measurement of electric current using ammeter, for the measurement of electric current, as like this, this is a ammeter A and as like this, and here using voltmeter V. In the situations, potential difference directly proportional to current, and V equal to Ri. R mean resistance, R equal to V divided by I mean resistance. And if resistance remain constant, then graph between potential difference and current as like a straight path, straight line, as like this, and this values remain constant for each time. And this is a angle theta, and this is a delta I, and this is a delta V. Tan theta means slope. Tan theta equal to delta V divided by delta I equal to R, mean resistance equal to slope. Is equal to slope of potential difference versus current graph, right? This is a basic relation, basic concept about the Ohm's law, right? Suppose that this is a graph, numerical problem, example first, and the graph between potential difference and current as like this, and here value of potential difference, potential right, 2 ampere, 4 ampere, right, current, and 8 ampere, 16 ampere, and here value of potential difference 2 volt, 4 volt, 8 volt, 16 volt. Find the value of resistance, mean R equal to V divided by I, mean 2 divided by 2, mean 4 divided by 4 equal to 1 ohm. And for the basic concept, resistance is a internal property of conductor. Resistance does not depend on the potential difference and also electric current, right, mean R equal to V divided by I. And now we are discussed about the ohmic circuit and non-ohmic circuit. What is the logic of ohmic circuit? For which circuit graph potential difference versus current along the straight line known as ohmic circuit, and for the ohmic circuit graph straight line R equal to V divided by I remain constant and the graph straight line, right. For conductors, and concept of non-ohmic circuit. What is the logic of non-ohmic circuit? As like diode, triode, transistors is a best example of the non-ohmic circuit. In non-ohmic circuit, graph relation between current and voltage in non-linears as like this, and here resistance, value of resistance delta I divided by delta V, mean R equal to delta V divided by delta I, and this value is also variable. This value of resistance, but resistance is not constant, resistance is a variable, and circuit example of the non-ohmic circuit as like the diode, triode, transistor, LED is a best example of the non-ohmic circuit. In non-ohmic circuit, graph relation between current and voltage as like this, as like this. This is a concept of non-ohmic circuit, and non-ohmic circuit not obey the Ohm's law, not follow the concept of Ohm's law. This is a basic logic about the ohmic circuit, non-ohmic circuit, and also the Ohm's law. Let us start the combination of resistance, series and parallel combination of resistance. Series and parallel combination. Combination of resistance. In a series combination of resistance, suppose that this is a first resistance, this is a second resistance, this is a third resistance, and similar n resistance can be connected in a series combination R1, R2, R3, and this is a n Rn resistance. All resistance connected in a series from the external source as like the battery, as like this. And in the situations, the value of electric current across the each resistance same, right? Value of electric current across the each resistance across the each resistance for same, mean remain same, but potential difference across each resistance can be different, right? Mean resistance R1, resistance R2, resistance R3, resistance R4, and similar resistance Rn. Potential difference V1, potential difference V2, potential difference V3, potential difference V4, and similar potential difference Vn, and value of electric current for the each resistance remains same. From Ohm's law, V equal to IR, mean V1 equal to IR1, V2 equal to IR2, V3 equal to IR3, and similar for last resistance, mean Vn equal to IRn. Total value of potential difference V equal to V1 plus V2 plus dot dot plus Vn, right? This is a very conceptual examples and very conceptual explanations about the combination of resistance, such as a very easy concept, no any difficulty here, and this is a basic logic about the combination of resistance and put value here of the V1, V2, V3 and Vn, and here I R equivalent equal to I R1, and I is a common factor from each step, here R1 plus R2 plus dot dot plus Rn, and I cancel out from left side and right side, mean LHS RHS, and R equivalent in series combination of the resistance, mean R equivalent equal to R1 plus R2 plus dot dot plus Rn. This is a basic formula about the resistance, mean equivalent resistance when all resistance connected in series combination to each other. And now discussed about the parallel combination of resistance. Parallel combination of resistance. Right. What is the basic logic about the parallel combination of resistance? Using the circuit diagram of the resistance, suppose that this is a resistance R1 and this is a resistance R2 and R3, and similar can be connected n resistance as like this. This is a Rn resistance. All resistance connected from the battery and also parallel to each other as like this. Potential difference V, and in the situation potential difference across each resistance remains same, mean resistance R1 potential difference V, R2 potential difference V, but current can be different, here current I1 and here current I2, here current IN, because at this point, at this junction point, current divided in n part can be equal or non-equal, both situation here possible, but current divided at the junction point, right. And from the using of Ohm's law, mean V equal to IR, mean I equal to V divided by R, and I1 equal to V divided by R1, I2 equal to V divided by R2, and similar value of electric current for the nth resistance IN equal to V divided by Rn. Now, such as total value of total value of electric current mean I equal to I1 plus I2 plus dot dot plus IN, and all value put here, value of I1, I2, I3 and also the IN, and here V divided by R equivalent, and V is a common factor from this side, and 1 by R1 plus 1 by R2 plus dot dot plus 1 by Rn, and V cancel out from LHS to RHS, and R equivalent in parallel combination of resistance R1 plus R2 plus dot dot plus 1 by Rn. This is a basic logic about this concept, right. And one numerical problem related to this topic. Questions. Suppose that three resistance connected in a series 10 ohm, 20 ohm, 30 ohm, right, connected from the battery 100 volt. Find the potential difference. Find potential difference across each resistance, right. Solve this problem. Initially we calculate total resistance, mean R equivalent equal to R1 plus R2 plus R3, and R equivalent equal to 10 plus 20 plus 30, means 60 ohm. This is a total value of resistance in a given circuit. And also calculate current in a circuit, mean value of electric current, I equal to V divided by R equivalent, and value of potential difference 100 divided by 60, mean this value I equal to 10 divided by 6, mean 5 divided by 3 ampere, and value of electric current remains same for the each resistance, because each resistance connected in a series combinations. Now, potential difference in first resistance V1 and here V2 and here V3. Potential difference from Ohm's law, V equal to IR, mean V1 equal to IR1 V1, I mean 5 divided by 3, R1 10, this is a 50 divided by 3 volt. This is a value of potential difference across the first resistance, and similar potential difference across the second resistance I R2, and put value here 5 by 3 value of electric current and R2 20, and this is a value of electric current, mean 100 divided by 3 volt, right. And value of potential difference V3 across the third resistance I R3 from Ohm's law, value of 5 by 3 multiply resistance value of resistance 30, mean 150 divided by 3, right, volt, and can be divided. This is a basic logic, basic concept about this topic, about this concept, and here we are discussed the most important concept about the current, electricity, drift velocity, resistance combinations, basic concept about the Ohm's law, drift velocity, and electric current, flow of rate of charge, and here we are discussed major point about the current electricity. This is a first video lecture about the current electricity. You are most welcome here, and here we are discussed each concept, every concept as like the NTA point of view for the JEE exam, JEE Mains, NEET, and also the board exam.